Good evening, and welcome to the Brain Trust, an open forum, open door, all purposes brainstorming extravaganza. Tonight, I'm taking up CAD again to help design an orbital food production facility with placeholder films and Cassie the Ragdoll, and hopefully, I can coax somebody like Capacitance or some other great thinker or whatever we can find uh, to join in the stream with us. Anyway, it's your weekly brainstorming session here on the Academy Debate channel. Welcome to the show, guys. You ready to start going over what we would need for an orbital space food production facility?
Yes.
All
In
right.
addition to everything that's been listed so far, we would
Yeah.
need a water recycle slash solid recycle like processing plant that can be automated in order to create things like uh, fertilizer for the plants that are currently there, watering the plants, and if we actually do decide to inhabit it enough, that humans would have water for whatever they need for eating, drinking, cleaning, bathing, stuff like that.
Excellent. Yeah, that's I did talk about self-sustaining in that list of things that I need to have. Also, you mentioned something earlier before we get started. Automation.
Yes, we already have small-scale automated farms here on Earth. FarmBot comes to mind. It's an open source, which guys check it out. It's really freaking cool. FarmBot is an open source farming platform that you can actually use and deploy into your own backyard, and it can scale upwards. So we can have a flower bed in the yard. We could have an entire field automated. We could have stations just automated, designed to grow nothing but food. So maybe we can have it 100% automated, like at the outset.
Okay. Anyway, I did promise a CAD episode, so keeping these kind of ideas in mind, it has to be very high Earth orbit, which means you're going to have a lot of opportunities to get hit by little things moving very, very fast. That being said, I thought it would be a pretty. Actually, let me cancel that. I thought it would be a pretty awesome idea to incorporate something we talked about a couple of weeks ago called Pykrete. And Pykrete is, beyond everything else, it's bulletproof. I don't know if I mentioned that.
You did, but I think for something very high orbit, we would need like an actual titanium alloy hull, something specifically designed to withstand impacts of that magnitude.
Well, you can have that with the layer Pykrete on the outside, which is more deflective than anything else. I'm trying to screen share. Okay, there we go. There it is. Let me make sure that I'm presenting to everyone. And we're good to go. So, what kind of overall shape are we thinking? Three-dimensional, by the way.
Personally, I was thinking more spherical. That way we can have it orbit. If there's nobody on it, it doesn't matter its orientation, so we can just cover it in solar panels or have it as one giant solar panel. I mean, that would still make it susceptible to chipping, like from stuff that's out in orbit, but depending on how far in the future we're talking, we might actually have some way to deflect it.
All right, I'm going to start with a general unit of 100 because we're in real scale here. So let's go ahead and kill that. Bring this over to realistic. So we've got a spherical concept here. go ahead and do that real quick so that we can get an idea. And there.
Okay. Now, we should have it. It's not going to be exactly small. We're going to have to farm on it. So I'm thinking we give it a 200-yard diameter.
Well, I set it at 100 on the outer diameter here. So that would just, let's see here.
Well, we can work with that. We can work with 100 yards. That's fine.
There. Now it's 200.
Okay.
I'm going to keep this out because this is my mirror plane. So, sorry if that bothers you. Here, I'll make it bigger. Get it out of the way. As long as it's there. All right. So, let's do this real quick. Oh, what am I doing?
We have floors that are 15 feet high. That way it allows for storage to be made in a spherical space. So we have the very outer hull, like the smallest rooms that are on the top and bottom of the sphere are like just computers and generators and batteries and just stuff that you can open panels to look at.
No,
every floor above
are
that.
We going with meters? Or are we going with imperial?
We could go with meters. So can you change it? Switch it over to meters.
I'd have to start a new one, actually. But you know what? Let's just go with 100, and because this is all in inches, so 1 inch equals 1 meter, and it would just scale its imperial to metric. And I can remake it once. You know, if we get a basic overall here, I can go ahead and scale it properly.
Okay.
So
if 1 inch equals a meter, then floor is 10 meters.
Are you sure you want to do that? It's like it's pretty tall, dude.
Yeah, well, you have to allow for the machines to move around and for the plants to grow.
You're talking
Corn
almost
can get
30.
pretty tall.
Yeah, but it's not 30 feet.
You're going to have an environment on each of these floors. You need to create an atmosphere that's ideal for each of these plants.
So on your outer scale, in your outer hull, you're gonna have the computers, right?
No, on the outer hull, we're going to have a solar panel.
I'm sorry, outermost deck.
Oh, on the top and bottom, it's going to be like maintenance stuff that if a human needs to go there, they can just open a panel and be like, "Oh, yep, there's the battery, there's the."
All right, I gotta address something that's the elephant in the room, and I think I want to address it early because we're in space. There is no up. Okay.
We can orient.
We're not going to be able to stack this. We're not going to be able to stack this thing the way that we would traditionally on Earth if this was a sphere sitting on the ground. Up is towards the center of the circle, or towards the center of the sphere at this point.
We can orient it towards Earth.
Yeah, I get that, but it will have no gravity within itself. Everything will be floating around. And so the best orientation for what is top and bottom, the bottom would be the outer hull, the top would be the center of the sphere. So if we're going 200 meters in radius, then...
So we're looking at it differently. You're thinking like an onion. I'm just thinking like slices of a sphere.
Yeah, you're not going to get a lot of space that way. Like if you're going to go,
it's only 100 meters, dude.
Yeah, but most of it's automated, right?
Yeah.
You could actually spin this on an axis and get artificial gravity in parts of the sphere. That would help with human accommodation. I mean, it would only be on the outermost edges of the sphere, but as long as you're rotating it on an axis, you're good.
Dolphin, it doesn't need humans.
I get that, but you're definitely gonna want. I don't know. People are gonna want to visit.
Humans operate in zero. Okay, humans operate in zero gravity all the time.
So you still think you should layer cake it as a sphere? I mean, I'm not opposed to the layer cake concept, especially since it's automated. But if you're gonna do it that way, why not do a cylinder? It's more practical.
Because we can just let it fall through space, and no matter which way it's facing, it will have solar power in addition to the batteries that are on top. We can also, as it falls through space, just allow it to like build up energy by putting gyroscopes in it. It can rotate, and those gyroscopes, as they rotate, can generate energy.
Not sure how. Not sure how that works. I haven't really looked into that, but I'm skeptical of it.
It's how ABS brakes work.
All right, so you want to layer cake this thing? You realize how much lost space you got. We need other people. If you're listening,
space.
What's going on in the chat? We need more.
Nothing.
We need more people in on this. Capacitance, get in here. If you're gonna layer it,
yes, anonymous. Yes, you can by rotating with a cylinder, but you don't need gravity if it's automated. Plants actually can grow in low to zero gravity environments.
And you can actually increase the atmospheric pressure to get them to give higher yields on each fruit or vegetable. But that's a different component to the overall structure. If you're going to do pressurized food production, then yeah, a sphere is definitely the way to go. But even then, you would want to onion it.
Okay, if you onion it,
you get more floor space.
Okay, based on the size of the current sphere, 100 meters in diameter, it is not that much space.
Well, no, it's actually 400 meters in diameter at this point because it's 200 meter radius.
Okay, it's still not that much space. You would want flat planes instead of spheres.
Well, let's see. What is 1 meter? Is so right about like that. From that diamond to my marker, it's about 3 degrees. So you get a 3-degree angle on a 1 meter. That's very interesting. Let's see. Let's go with 10 meters real quick and see what the angle is. Four degrees. Okay, I'm gonna guess that that first one wasn't accurate. Let's go with 20, or at 30 meters, you've got a floor that is sloping. Come on, move it. That's still saying 4 degrees. Let's see here. Get a true judgment. Seriously? Alright, here we go. Sorry about all this, guys. Trying to get it settled up. I'm just trying to determine the slope of the floor at 10 meters. So, let's see here. Okay. Alright, I'm not liking this 2019 measurement concept. Yeah, just want to do that little circle right there. There you go. 3 degrees. So we got a 3-degree floor slope over 10 meters. I don't know. That's on the outer hull. Once you start getting in, you're going to lose a lot of height on your floors. So I honestly don't think a sphere is the way to go.
Well, here's concentric interlocking spheres are a bad idea because of that reason. As it gets smaller, you lose more floor space. Having it layered will allow you not only to segregate each crop you're growing, but it will allow you to optimally plan for each yield as well.
I don't know. I still think that the cylinder is the way to go. Let me throw this off to the side and just recommend, because this is one of our multi-week projects. So we're going to be working on this for quite some time, and I really want to get it right. And those of you who don't know, we are going to be continuing projects for over the course of months to really start coming up with some good ideas. Let's see here. I guess I'm going to have to slice it like that, aren't I? I like working with planar objects. Really? Really need a new keyboard. Oh, and I am going to blame a little bit of this on the fact that I've been drinking. So should be better than this at CAD. So you've got a system like this, right? Where you have your layers. Let's go down. And how you said you wanted it 15 meters? So this would be one floor.
Well, like 10 would be sufficient, but 15 would work as well. Most of these floors are just being used for growing crops. It's not like they need that much space. 10 meters is certainly enough.
Well, I mean, crops include things like trees, right?
Well, no, we're talking food specifically. Like,
Well, I mean, there are a lot of tree-grown crops.
well, sure, if
Blueberries.
you wanted to grow like fruit, but I was thinking more for things like staples like corn, wheat, rice, soy,
Grains. Well,
grain.
with
Yeah,
rice,
like
rice you need a lot of water.
we can we can address that issue later. We can actually harvest it from comets.
Mm. Wow, I just realized we do need gravitational forces on this because of the amount of water required for this project.
We can have the water like no, yeah, you're right. We would need gravity. Well, we would just pressurize it. We can pressurize it and simulate gravity with that way. We don't need to necessarily like sacrifice the design.
I don't know. I think having gravity on it is just at this point just a really practical concept. Let's go ahead and if you're gonna have gravity, you might as well go with the cylinder idea because you can rotate that along the long axis. Are you kidding me? You know, sometimes I really hate this job. All right, there we go. So that would be like floor number 1. Let's go ahead and have some fun with this. Rotate it around the axis and do that kind of thing. Okay. Oh, wow. Let's just do it like this. It's probably a lot faster. Oh, are you kidding? There we go. I'm not used to this program. I really want to use one that I have from work for the Pie Creep project called Plant 3D. It's an awesome program. There we go. Oh, we've got a floor cut out. And we're going to give them, what, a meter between floors for insulation, piping, wiring, that kind of things?
Maybe 3.
It's a lot of space.
That is a lot of space, but this is going to be a massive space station. We need as much going through the floors as possible.
And you do need
heating, water. We're going to have a lot of electricity flowing through this place, so it's more than just electricity keeping all of the plants going. It's going to be electricity for all of the bots that are tending the plants as well.
Let's go 2 meters down. Because a meter's pretty big, and you'd be surprised how much piping you can put in 1 meter if you do it properly, you know. So we're going 15 meters per floor. Is that about accurate? 15 meters per floor?
Yeah.
I hate these things. Switch over to wireframe. So, not to scare you guys, but just see better in this. Now I should just do a polar array. Or, I'm sorry, a path array. But I'm too lazy to mess with it. And this is the beautiful part of all that. How many floors do you want?
As many as can reasonably fit.
And how long are we making this bad boy?
Well, I had initially planned on going with the cylinder, so
We got a 200-meter radius.
I guess we can make it 400 long.
Wow, what was that? 400 long?
Yeah, dude, this thing is going to be able to feed like an entire state. And we can just have these parked above the earth with that send down like rockets full of food that just fly back to the station. Or we have a separate station that's for fueling and maintenance of the rockets themselves. But we have it like on a constant rotation. That way we're able to address mechanical failures and metal fatigue.
So that's your overall cylinder right there. Let's see. There we go. Now, it's just a matter of grabbing all these little micro cylinders. No. I meant deleting them. There we go. This is your overall concept design. And yeah, probably should have scooted that in a little bit. At least this way we get an insight to the whole picture from the side. You can see all the way through the levels. There we go. So I'm thinking you wanted computer and processing and all that stuff on the outside of the overall structure, right?
Yeah, that way if something big does actually hit it, there's an extra layer of cushioning. I mean, yeah, the plants would die eventually. It would give us a few days of like life support and in like a viable environment before like oxygen leaks actually become a problem on the satellite, or any other sort of mechanical problem emerges, like a fire breaks out because of the damage to electronics. So it would be a way to kind of insulate the actual valuables within.
So this is so that's a 20-meter space between the outer wall right there, and then you have all this gross space in the middle. So you've got 10 meters, like between here and here, you've got 10 meters worth of computer components that are against the coldest part of the platform. Then you could actually put up a wall right here.
We can also put heating fins on the outside of the satellite itself to act as the biggest heat sink in history.
Yeah, but you also need that same space for solar collection, right?
We can have like actual panels on the top and bottom of it pointed at the sun, as well as fins. Like, there are more options available than just having it on the satellite itself. It wouldn't be a bad idea to put it on the satellite, but if we wind up needing that space for cooling, then we can have parts of it for cooling and the rest of it for solar. We can have modular panels on the outside of it that we could utilize as we see fit.
All right, let me hope you guys see this a little bit better. So you've got this platform, and sorry about deleting your outer wall there.
I can't believe you've done this.
Yes, I know. Everyone's going to freeze now. But we're looking at just one floor here. You've got the computer area right here, a little bit of space, about 10 meters of open air. Then you've got a 2-meter thick insulating wall. And everything inside here, actually this is the lowest floor, so you'd probably have storage and docking. And then the same thing on this end, storage and docking. And then you'd go one layer down before you actually start production. You can also have water storage. Actually, you know what would be a pretty cool idea? Be to, let's go ahead and copy paste that real quick, and then scale from right here. Oops. Yep. Let's try that again. Yeah, that's not what I meant to do. Take 3. Little yellow, different. Where's my mouse? Ah, damn you, AutoCAD. All right, I'm over to my secondary mouse. All right, so now we have a wall inside of a wall, and I'm thinking this internal area, or this interior area right here, water storage. You were talking about an extra cushion, right?
Yeah.
What do you think? It's an outer ring, so you've got a huge amount of total volume. And it doesn't have to be that
material that it's made out of. Yeah, that could work.
Yeah, you could literally have like just 5 meters of space on the outer ring on every floor, and you've got water storage. And that puts the weight on the outside, so if you do get it spinning, the centripetal force will keep it going. All you got to do is get it started. That'll be interesting fluid dynamics in space. You okay over there, Cassie?
Yeah, I'm fine. I'm dealing with a 12-year-old who doesn't want to go to bed. A 13-year-old, sorry.
Oh, there's oh wait, never mind. We can't recommend child abuse on this network.
Just tell her there's no bedtime in space.
I have no ideas in that case.
Because in space, no one can hear you scream.
All right, so let's see here. Inside, you've got you've obviously going to have your piping. Goes. Let's see. You know what? I'm just going to draw lines. You guys are going to have to use your happy little imaginations. All right, so you've got these pipes that are going in. You're going to have what, about 1 to 2 meters worth of soil space on each given floor, or at least piping and hydroponics.
Yeah. Because we can also use the hydroponics to also farm fish.
You're talking about hydrofluorics.
Sure.
Okay. Why is that moving? That's not what I wanted. I hate this. Hey, having a bad CAD night. All right, so wow, changing UCS. You gotta love that. I just can't win, can I?
Well, you gotta have patience with it.
Oh, I realize what's going on. This is my backup mouse. So if you don't hit the left mouse button just right, it double clicks. I was wondering why it was like cycling through the commands without allowing me to do anything. There we go. Okay, so you've got this pipe running up the center, of course. On each one, you're going to have branches coming out, working with hydrofluorics. here's an interesting question. To gravity or not to gravity? If you don't gravity...
If we're going to have fish, we need gravity.
And presumably, those fish would be in the water section, correct?
Yes.
Then you're going to need more than 5 meters.
Yep. Partially why I was suggesting the height of the floors as it was.
I would recommend... Okay, so here's what we do. We go 15 meters in. After the first 15 meters, we give it another 15. Let's see, that would be... Make that a 5 meter thick wall as well. Probably should have thrown wireframe on there. There we go. Wow, that is a large freaking wall. Let's go 163 and throw in the wire.
And see, we would wind up having to have fish on the satellite every 5 to 10 meter, 5 to 10 layers. That way it could provide ammonium to the above and below floors, as well as nitrogen to act as a fertilizer. That way we don't have to bother too much with the water pH. It'll regulate itself.
Yeah, I've looked into hydrofluorics. They're pretty interesting things. So you've got this... Let's try that again without all the triple clicking and stuff. So you've got this section right here is hydrofluorics for the fish. 15 meters from inner ring to outer ring, and 15 meters top to bottom on each floor. Inside here, I would, for safety reason, I would expect a flood control area. But then again, it could be built into these 2 meter thick structures right here. Anyway, from there you have the piping. Say about another 5 meters worth of clearance space for piping and easy access for wiring and stuff like that. So you've got plenty of space without things being real tight. And then that leaves us a radius of approximately, yeah, you got about 150 meters. 150 meter radius of growing space per floor at 15 meters tall. It's pretty big. So this is your actual growing space right here inside this circle.
Mm-hmm.
I've really got to set some templates up for this thing before I do another broadcast. Anyway.
We should also start adding notes.
And give a little 1 meter platform there. So you can see this would be your official growing area. Let's make that green. And let's make this blue. All right. And this is going to be repeated on every level?
Yeah, but each level will have the ability to grow different crops. So it won't necessarily be the same crop, but it will be similarly structured on every level.
And it won't necessarily be the same fish, I take it.
Right.
Okay.
We can actually match the amount of ammonium produced by certain fish up with the correct plant that requires that much or more. And that way we can always add more to the water on that layer, or we can take where there's excess from one layer and pump it into the other layers. That way we can regulate each layer in terms of its environment, precisely.
Can I point out something really awesome about this concept design? Because it's orbital. Pykrete works really well. You don't have to worry about keeping it frozen. It just stays frozen.
We would also need at some point to build a sort of spaceport onto it. That way we can send the food off of the satellite using the reusable rockets.
Yeah, that's what I was pointing out for easy docking. Not only that, here's the problem with an orbital space platform. You have to constantly resupply it with water. And the reason you have to constantly resupply it with water is because every food product that comes out of there means that you're losing water.
Sure.
So you're going to have supplies of water coming in, and I'm thinking that you're probably going to have some sort of off to the side tank or something like that, It's just let's see here. Something like that. That probably went all the way to the top, more than likely.
Yeah.
Really? You're going to be like that? Fine. I win. Sometimes I really hate AutoCAD. How many of these tanks do you think we should have? You want to
probably
keep
wouldn't
it.
Be a bad idea to have maybe 3 or 4 of them.
Let's go with 3. And let's do this real quick, just for grins and giggles. There. Yeah, and you really want it to be arrayed on a polar symmetry so that you can keep it well balanced as if you want to put a gravitational force on it.
Could you cut out a cylinder starting from the very center of the cylinder out to about 30 meters? We can use that as an access/loading shaft to go throughout the entire satellite.
Oh, you're going with the similar idea to the pod there. Now, do you want that to be diameter or radius?
Radius. Let's make it a little bigger because we're going to have tons of food coming off of it.
Yeah, but 30 meters, it's a pretty good size, man.
Yeah.
So how big do you want it? 40?
60 meter
35.
diameter.
60 meter diameter?
Yeah,
Alright.
so 30 meter radius.
Oh, okay. Yeah, alright. I was just checking. Let's go ahead and do a second circle while we're at it. Good measure. That's give it a 2 meter outer inner hole, I guess you would call it. AutoCAD really wants to be difficult today. Let's see here. Wasn't supposed to happen. Alright, so let's go. Alright. Okay. Now let's see if that worked the way I wanted it to. No, it did not. Yeah, I thought I did that. Sorry about this, ladies and gentlemen. Try not to break it, okay?
Mm.
Let's try this again. Alright, so here's your port of entry. Got you a little extra lip there. And of course you've got this wall for protection from the elements. So you're going to have shipments coming in and out right there. Correct?
Yep, from the top and the bottom.
Yeah.
That way we can maximize use of that space as best as possible. We can use the center.
Giant solar panels right there.
Yeah. We can use the center. We can have drones that fly from layer to layer collecting things. Because it's going to be a pressurized environment. It's not going to just be open space there. That all collects it into bins that sends it, loads it onto the payloads in the rockets that get launched off of the satellite into the atmosphere and ultimately to the Earth. Or whatever planet it happens to be orbiting. We can use this on any planet.
Let's go ahead and do this. And let's jump back over to the model. Take that out. Back to the layout. That mouse again. Really, what is all that? There we go. Let's turn folder tracking off. What should we call this? Transport? Because it's not just going in and out, like you said. It's transporting level to level. So you've got these top.
Logistics, I think, would be the better way to
What was
think
that?
of it.
Logistics.
I think logistics would be the best way.
Yeah, that's. All right, so what I'm thinking is you've got 1 or 2 layers of storage and delivery, and then this tunnel has a cutoff, like a straight up solid wall cutoff. And then between that point and 2 floors from the bottom, you have inter system transport. And on the ends of that cylinder, you have, this is where the little robots come drop off their loads in the storage facility, which is, of course, on either end of the overall platform.
It would also have to be a landing bay for humans. It has to be accessible to humans, even though humans are not going to be on the satellite often.
Yeah, they're probably only going to be on the first 2 floors, and maybe the 3rd floor in, which will be, done up more like a showcase floor than anything. But
Yeah.
everything in the middle is, most people are never going to see it. And you still have that central vein for everything to go in and out. Let's go ahead and save that. There we go. I really want to jump back into this, and let's go ahead and Magenta's not too hard on anyone's eyes, is it?
Okay.
Oh, crap. Let's make this. Let's make it a light blue. It's not too bad. Make that back into green. Oh, I missed something. Make that a dark blue. Oh. And let's make these things orange. There. Now, a little bit easier to see in the drawing. All right. Well, that brings us around to the end of our show, ladies and gentlemen. We have got a basic overall concept of what we're looking at when building an orbital food production facility. Over the next few months, we're going to be bringing this project back up by hook or crook. I'm sure we can find a way to keep the CAD shows going. And in the meantime, thank you all for joining the Brain Trust. Just for future reference, we're looking at a name change here real soon on the channel, so get excited about that when it happens. Anyway, you guys have anything else to add to this incredibly quiet episode of the Brain Trust?
I think that's it. That's really about all I've got for it.
Cassie, next time we have a show, can you please stop talking once in a while?
I will try.
I couldn't get a word in edgewise.
I know that you have a lot to say. I get that. I get that. But Placeholder and I want time to talk too. That being said, thank you all for joining us. I'm going to go ahead and close down here and wish you all good night and good luck.